All right, why don't we go ahead and get started? You gonna close the door? Oh. All right, my name is Alan Stewart. I'm a group program manager in the Windows Server and System Center Engineering Organization, and I have a special guest with me today. Phil, you want to introduce yourself?
Hi, good afternoon. I'm Philip Moss. I'm one of the founding partners of NTTX. We are a UK-based service provider who specialize in hybrid cloud and public and private cloud solutions.
Excellent. So in this session, we're going to take some time to really kind of talk through building out a service, right? What does it entail in building out a service, and what are some of the challenges you have in building out a service? And also, I'm going to talk about how in Windows Server and System Center, our North Star is focused on building a shared multi-tenant service. And why do I want to cover that? It's because typically in development, you see a lot of different features, and you see features come in and out. I want to let you know that there's a North Star that we're shooting for, and it's building a perfect shared multi-tenant IaaS service. That is our goal in Windows Server and System Center. So whatever you learned or heard about this week around R2, it's all about getting to that North Star, right? You heard in the keynote from Brad talking about the service, and there's different features, and people talk to you about different features, whether it be Hyper-V replica or storage. This is all part of a holistic approach toward marching towards that shared multi-tenant IaaS service. All right, so we made that switch in 2012, and we're continuing down that path. And then I want you to actually have some time for Philip to talk, because Philip actually runs the service. So how is he using some of this stuff? It's one thing for me to talk about and pontificate on what we're doing in development, what's our North Star around building out a cloud service, but Philip brings the practical experience of actually using the technology and running a live service that people actually pay money for. Right? All right, so we're going to focus on service. We're going to talk about some areas of a service. We're going to talk about compute, network, and storage. Now, we could talk about compute, network, storage, identity, management, but then you would be in this room with me this entire conference. And I think you want to go and see some other stuff, right? So we're just going to tackle a few different areas. And even then, I'm going to be pushing along so we can get to Philip. So I'm going to cover these areas. There's much more to building a service, but we don't really have a whole lot of time to kind of cover some of the big three, right? All right. So what about this focus on a service? So from an engineering perspective, we consider everyone a service provider. Everyone. So there's different types of service providers. Some people actually charge and build public cloud services, and they have charging today. They offer services to external customers. So you go, like Philip's organization. You go, you can select the VM, running services like Exchange, Link, or SharePoint. Some of you are enterprises where you offer an internal service. You have business units that you supply applications and workloads to. Would anybody in here dispute that they're a service provider? Exactly. So our mentality is everyone is a service provider. So when we're building out this shared multi-tenant IaaS service, we're building it whether you decide to build it and use it on the public cloud or whether you decide to use it internally. So it's all about engineering towards this service-oriented architecture in every component. Storage, networking, identity, everything is marching towards that one design goal. Okay? So in 2012, we started out development after in R2, we added live migration, had a bunch of different features to Hyper-V, started to get really compelling to run Hyper-V. In 2012, we took a different approach. We said, okay, let's take a step back, and let's look at what we want to build to enable a service. What does the perfect shared multi-tenant IaaS service look like? And let's engineer components toward that North Star. So in 2012, I don't know many of you how many people knew that we had this pillar and this overarching approach that we called the hosted cloud. And we were building stuff in 2012 towards this moniker called hosted cloud. All right, that's really compelling. I'm surprised anybody actually knew. All right, so what is a hosted cloud and what features do we add in to build around it? So in 2012, you saw a lot of different work. A lot of things came into development in 2012. You saw storage spaces. You saw SMB Direct. You saw CAU, 64-node clusters, network virtualization, and all these different features that when you look at them by themselves, you say, okay, those are pretty cool things to add. But all those things were marching towards an end goal of building a shared multi-tenant IaaS service. So I'll give you, for example, network virtualization. Why is network virtualization in the platform? Anybody think they know why it's there? It's there because service providers have this challenge. When you want to isolate workloads, the way you isolate workloads today is by using VLANs or PVLANs. All right, pretty reasonable, other than the fact that it's security by obscurity and it's easily misconfigured. Well, we won't talk much about that. Every time you add a tenant, you add a VLAN. So service providers had 5,000, 6,000, 7,000 VLANs. As they were more successful, their VLAN management problem exploded. That causes you to have different edge devices. Certain switches only support 2,000 VLANs per device. And to manage 6,000 or 7,000 VLANs, it's ultimately an unsustainable problem. So we said, how can we provide policy-based isolation that Coke and Pepsi would want to run on the same hypervisor, they'd be isolated, and the policy would actually travel with the VLAN and flatten out the network in this service. So it wasn't around moving VMs between different environments and not changing IP addressing. That was a byproduct of the actual problem. The problem was, how do we flatten the networks and move service providers away from using VLANs as security? So with network virtualization, you can flatten your network, have policy-based management, red-blue network, never miss any miscommunication, security at the networking layer, and oh, by the way, you can move VMs around your environment between data centers without having to think about the IP namespace. That was a byproduct of the actual problem. Hyper-V replica. How does a service provider build a service for doing DR? So the real delineation in a service provider, internal and external, is every time an external service provider adds a service to the environment, that's a chargeable resource. So you don't add DR just because you can add DR. You add it, and that's a consumable service that somebody can actually use. So how do you add protection of the virtual environment in this service? So Hyper-V replica showed up, right? Allowed you to do planned and unplanned failover, and service providers actually took that and built a service around it. Services that they can monetize over and above shared multi-tenant IaaS. Because shared multi-tenant IaaS by itself is pretty compelling, but the services that you can build on top of it to continue monetizing it is really the direction that service providers are taking. So we focused in on building a shared multi-tenant IaaS in 2012. We delivered features toward that. In R2, we improved on some features, but still that North Star was a North Star. Okay? And some things we actually made deployable, like network virtualization. Before we took a dependency on a hardware gateway, now we have a software gateway, because we heard clearly from service providers taking the dependency on a hardware gateway was impeding their deployment of network virtualization. You also saw the notion of the fabric consumer concept, right, in the System Center. System Center had a fabric administrator, a person who would build out cloud resources and add resources to a cloud. And then you had a consumer. You saw in the keynote the Azure Cloud Pak and the Azure services all coming in. So that's the portal experience for consumers. So if you're building out a shared multi-tenant IaaS environment, there's a fabric management experience for managing devices and the data center, storage, management, compute, tiering, and then there's the consumer view. So if you're a service provider, the consumer experience of signing up, billing, and looking at the resources is almost as important as the fabric management experience you have. So there's a consumer view on top of it. How users actually consume resources. Can they see what resources they're using? How it's being leveraged, billing, usage, all that came together, right? All right, so what are some of the service provider principles? So I'm a service provider, I'm going to build a service. Where do I start and what do I think about? The first thing is I think about how much is the service going to cost. Why? Not because I'm thinking about my monetary value of it. I'm thinking about how do I charge somebody for this service. Right? What am I going to charge somebody for a VM? I'm delivering a VM. How much does it cost for me to deliver the VM? And service providers use that to determine and make architectural decisions. Now, what I've found in dealing with service providers and maybe dealing with enterprises building out internal private clouds, sometimes that's flipped around. Enterprises have decisions that they've already made, a particular type of storage that they want to deploy, a particular type of networking that they want to deploy. And all those decisions, when they make them, either drives the cost of the VM up or drives the cost of the VM down. So if you were a service provider today, you would let this kind of help you dictate what architectural decisions you make, particularly at the storage, the networking, and the compute level. You'd probably make different decisions. When you see the VM costs go from $10 to $150 based on the type of networking you use, the type of storage you use, right? So service providers are into flexible approaches. So they want to be able to leverage different types of hardware choices. So do they go out and purchase the highest end storage platforms? Potentially, but they want to be flexible. They want to be able to use commodity components to build the service out. Because the cost of the decisions and the choices they make around hardware ultimately dictates the cost they charge the end user for the service. Okay? And they want to have a super tenant experience. So I talked a little bit about this when I talked about the portal experience. The way that a user interfaces with a cloud service is through your portal. That's everything. That's the way they see you. They don't see a human being unless you have one of those little robot chat ladies on the front page. They don't see a human being. They consume your service through this portal. They'll sign up. They'll sign in, pick services, look at billing. They'll look at the usage reports that they have. This is the way they interface with your service. So having a very streamlined tenant experience for signing up and consuming resources is all an important part in building out a service provider. Right? So you can have the best fabric management, ultimate provisioning, storage environment. If you have a crappy front end, then that's where the users see you. Well, this is probably not a good service. It takes me so long to sign up. Do I really want to use this service? Okay. And automation. Automation is critical in the service provider space. It's not an option for you not to have automation. Everything is automated. From the time that you sign up, a user signs up, goes into your service gallery, and that gets provisioned out in your environment, and they get a success message saying your service is ready to be provisioned. That's all automation. Automation at the task level, run books, recipes, everything, all the tasks and run books are all automated. So something like create a VM is a task that gets automatically spawned when the user selects a service. I want a Windows server from the gallery. That kicks off and there's automation that goes along with it. So there's a ton of automation there. Scripting, APIs, RESTful APIs, standard-based APIs, and standards-based management. And now that you have this, at least a base layer of shared multi-tenant IaaS, you would think, well, look, I got a hosting service. But you don't build a hosting service just to have a hosting service. You build it to build compelling services on top of it. Just having a shared IaaS hosting service is nothing without having additional compelling services. So I like to say it's the service provider's way of taking a $10 basic VM to $150. Now, how do you do it? Here's a basic VM. Do you want to back it up? Yeah, that sounds great. I want to back it up. That's extra monetization. Do you want to add DR, multi-site failover? Extra monetization on top of it. Do you want cloud storage? There's extra monetization on top of it. You want backup, archiving. And oh, by the way, would you like me to manage the VM and the application inside of it? You do? That's extra monetization on top of it. So it starts off with the shared basic IaaS infrastructure, but then there's compelling services that you have to build on top of it. Because if you plan to build a business just on hosting virtual machines without additional compelling services, that's probably what service providers call the race to the bottom business, right? Eventually, that's going to be so cheap that anybody can do it, and it's not going to be any margins you're going to be able to make on top of it. You have to build additional services on top of it, right? And interop is really important. So one of our core principles in engineering is there should be no difference in parity between a Windows guest running on our platform and a Linux guest running on our platform. Meaning, if Windows guests support 64 virtual CPUs, a Linux guest should support 64 virtual CPUs. Because think about it. You as a service provider, do you really care? Your consumers are going to say, I want to run this workload, and they don't want to hear limitations in the workload. If there's limitations in the platform to running a workload, there's limitations in your service, and that limits the amount of consumers that you can actually go after and reach. So we've made that core principle that Linux and Windows guests should be at parity. And I'm going to talk about some feature areas that we're doing specifically in R2 to make that happen. Even Microsoft writing code and putting it into the Linux kernel branches and having it accepted to ensure it's at parity. We took that responsibility, and that's stuff that we're actually doing. And live site operations. You're running a service now. You're not running a server. So there's the different ways you have to look at managing the service. And this affects us from a tooling perspective. In the tooling, you have to have visibility of the service. What capacity do I have in the service? What faults do I have in the service? So you're looking at it more from a service view, and that affects the tools that we actually use, and that affects how you actually go about managing the environment. You're looking at it as a service. You're not looking at it as a single server, right? So everything is a service. The disaster recovery service, what are the components that made up of it? So you see some of this early, in the early operations manager days, right? This was service, the diagram, and then all the components. But this is just taking this to another level, right? Capacity management. How do I manage capacity in this service? And I call it the service provider's best, worst day. The best day is you sold 3,000 VMs. The worst day is you sold 3,000 VMs. Why? Because now you need to go do some capacity management jujitsu around how much capacity do I currently have, how much capacity is this new customer going to consume, and then how much hardware I need to buy. And today, there's a lot of sophisticated tools that service providers use to do it. It's a tool called Excel that they use to do this activity. Believe it or not, that is the tool of choice. And there's generally one person in a service provider that actually knows how to actually calculate capacity. One guy, they go to him, he does some magic and says 16 compute nodes. We need 16 compute nodes to service this workload. And nobody questions him. It's like, okay. What he's done is he's overallocated the amount of space that he actually uses, right? He's got his formula. 16 compute nodes, he needs about 8. So he's never going to be wrong, right? He's always going to be right. Extra amount of capacity. Okay, so let's talk about compute. What are some of the challenges from a service provider perspective on compute? So we talked a little bit about it. How much capacity I have today and how much do I need tomorrow? Why is this important? Because you can either over-allocate your environment and pay for power, cooling, and resources that are running that you don't have any consumers for, right? That's one way to do it. What's the pro to that? You're never out of resources. What's the con to that? You're using resources that nobody's paying for, right? So you dance on a needle there, right? Noisy neighbor problems, right? So now you're running a service. You can't, the workloads that consumers are going to be running are going to be all over the place. Somebody could have a very IOP-intensive exchange environment, a very IOP-intense database environment, and you have to plan compute resources for the entirety of the workloads that your consumers are going to deploy. And if you ask yourself as a service provider, what are going to be the workloads that my consumers are going to deploy? Everything. Compute intensive, IO intensive, network intensive, and you have to build the service out to be able to handle all those different types of workloads. So this filters through compute, storage, and networking, but this shows up across your service level because you have no deterministic way to determine what consumers are going to run. They're going to run everything. So demanding workloads. You have to be able to run demanding workloads without other workloads affecting other consumers or tenants. Everyone's a tenant now. How do I control resources across tenants? And how do I ensure one tenant doesn't destroy another tenant's experience? Right? A little bit different thought process now that we're looking at it as an entirety of a service versus looking at just a simple virtualization environment, right? And it gets even more interesting when tenants are paying for guaranteed resources that you have to deliver at the threat of monetary penalty. If I don't get 1,000 IOPS, you owe me $50, right? And also the billing area. So there's two types of billing that service providers do. There's consumption-based billing, or you know it as the cloud purist usage-based billing. I pay for what I use. And then there's monolithic t-shirt size billing. Small, medium, and large VMs. Here's a small, one CPU, certain amount of memory, certain amount of storage, and then you size it up from there. Service providers want to get to consumption-based billing. Monolithic is okay to start, but you leave resources on the table, right? You don't charge people for network ingress. You don't charge people for storage IOPS. Usage-based billing is where service providers want to go. It's just complicated to get there around the consumption model. A lot of the large service providers have built tooling to do consumption-based billing. Now, what are some of the things that we specifically did in R2? Specifically focused at compute resources. I know in it itself, this seems like a lot of different features, but they come together, all these things come together to deliver a service. So in-place virtual machine migration. Why is this important in a service? You have 64 node clusters, you have clusters of compute resources, you add new compute resources running R2. Do you take downtime to move those resources over? If you did, you'd have to pay your consumer money, potentially, depending on what SLA they had in their environment. You want to be able to move capacity to new capacity, because as a service provider, you're always adding capacity. You may have to move capacity from 2012 to 2012 R2. In-place live migration allows you to move capacity without taking any downtime from a consumer perspective. Faster live migration. So you want to evacuate nodes. You're running a service. You want to evacuate a node off because you want to do some patching. You want to do some maintenance on a node. To move 40 virtual machines from a node can take anywhere from 30 minutes to an hour, depending on the size of the virtual machines. And remember, you're running a service. You don't know, you have generally no clue about the size of the VMs that the users are running. Some are large, some are small. So adding in the ability to do compression over the wire or using RDMA to evacuate a node gives you some maintenance benefits when you're running a service. Resize. How many users will say, I want to be able to expand the virtual machine that I have to use additional storage resources? You could say, well, spawn a new one. Then you have a migration problem in the application. Or you could say, sure, we could resize you. Go to the portal. There's a task called Resize VM. Add additional capacity, and we'll start charging you for it immediately. So all this stuff goes into how you manage the service and how you handle your tenants and how you continually be able to provide that shared IaaS experience for them. This is an experience feature for a tenant. If they had to actually go into another virtual machine just to add additional storage, right, that's not a good tenant experience. Right? Export and clone. User just wants to be able to snap a copy of an image they already have. You want to offer a task that allows them to snap a web server, the content on it, and spawn additional web servers. All right? So this gives you flexibility in being able to export the workloads, clone the workloads, protect the workloads. You can clone it, replica it, ship it, back it up again for a customer. So this all goes into making it highly available. Storage costs, noisy neighbor problems. Right? While this falls under the compute area, noisy neighbor problems falls under network, storage, compute. How do I guarantee resources? Right? Storage cost is one of those capabilities that allows you to guarantee resources to an end user. And my favorite one, right? So I mentioned that if you're going to run a service, you have to have parity between the services that consumers want to run. And we all know that it's only a Windows world and everything just runs Windows Server. There's nothing else available for users to use, correct? Everybody with me? No? There's other stuff? Wow. Okay, so Linux guests. So parity with Linux guests. How do we make Linux guests first-class citizens on our platform? You're a service provider. You need to be able to support your consumers. So some things that weren't available in Linux guests that were available in Windows guests. One of them was dynamic memory. Why is dynamic memory important? Right? The ability for you to be able to balloon and add memory, shrink and grow, helps you as a service provider be able to have a consistent level of memory, but also helps a user. User has an application that needs more memory, you can allow them to grow to a certain point, and you can charge them for that resource, versus having to resize them or have their application take a bad experience when it uses over the amount of memory that you've allocated to the virtual machine. Of course, this is something you as a service provider want to charge for. The other thing is application consistent snapshots. This is something that Windows does through VSS. Integration with VSS in the Windows guest allows you to take an application file level consistent snapshot. And that's something that wasn't available in Linux before, because the VSS infrastructure is not available in a Linux client. So now we've taken the Linux functionality, rsync, and snapshotting, and enabled that level of functionality on the platform. So now Linux has parity in being able to take online live snapshots of Linux guests. So this is something that you could even offer as a service to your clients or allow them to do it from the portal. Right? So now you don't have an inconsistent experience between Windows and Linux guests. Okay? So parity is where is an area that we're focused on, because you as a service provider have to focus on parity. Right? And also the thing that I mentioned around online resizing and VHDs, this applies to Linux guests as well. So now you have a good experience for the types of distros that you want to run as a service provider. All right. Shared VHDXs. So consumers are going to run workloads on your environment that may need clustering. Before, there was only a few ways to offer clusters. You either had virtual fiber channel iSCSI. This may not necessarily fit with your storage architecture and directions if you decided to go with file-based storage. We would force you to go back into iSCSI or fiber channel storage just to be able to offer your tenant the ability to cluster a workload if they're running something like SQL. Now with shared VHDXs, if you're running file-based storage, now you can actually have you can actually cluster with shared VHD files, SQL, Exchange, SharePoint, and offer that as different workloads to your consumers without forcing you to make architectural decisions around using iSCSI or fiber channel-based storage. So now you have flexibility. And as a service provider, this is not something you offer for free. If a user wants to cluster their workloads and add additional protection, that's additional money that you can actually monetize the environment for. Okay? All right. DR. This is a service that all service providers want to offer. Why do you want to offer DR services? Because consumers, as they get more demanding in consuming cloud services, they want something better than what they've already had in their environment. If they're already doing something like replication or DWDM, backup between data centers, they expect your service to be able to provide this level of capability. Right, so what did we do around DR, specifically around this shared multi-tenant environment? So we started off in 2012. Our DR journey was we wanted to have DR. Right? We didn't have anything like Hyper-V Replica in the platform. Right? So you had virtual machines that there was no synchronous mechanism or even async mechanism for you to keep VMs in sync between multiple data centers. So we added in the concept of Hyper-V Replica. Hyper-V Replica gave you 15-minute replication between two endpoints. It's a good start. But we heard from service providers, this is not enough. We have users who want to have near synchronous replication. So as a service provider, you want near synchronous replication, that's a good another amount of a compelling service I can add in, and I can charge you for it. Right? So in our evolution to 2012, we wanted to make it enterprise scale. Right? And making it enterprise scale was changing the replication interval and getting to near synchronous replication. So what were the design principles? So one, it had to be simple. DR is complex enough. We want to add additional complexity into it. Right-click, enable a virtual machine to be replicated from data center A to data center B. Select the interval and step out of the way and allow it to replicate. We want it to be manageable at scale. You're a service provider. You're building this out. At any one time, you may have 10,000 virtual machines that are replicating. And we wanted it to be granular. So you, as a service provider or as a tenant, can decide when they want to use replication. Some workloads you want to use replication for, some you don't. Maybe stateful databases, but not websites. So we wanted to allow it to be granular, and we want to have a consistent user experience. So as a tenant, selecting, I want to have this replicated from data center A to B, but from a fabric administrator perspective, also having an experience for being able to manage at scale the amount of replicas you have in the environment. Okay? So in R2, the major feature area that we added in was the ability for you to now have configurable replication. Before it was 15 minutes, non-configurable. Now you have 15, 5 minutes, and 30-second replication. When you're at 30-second replication, you're at near synchronous replication. Right? And this is all something you can add on and add on as a service and charge for in your environment. So it makes your service more flexible to have more flexible DR options. Okay, storage. Now this is the big one. Right? What are some of the storage challenges that you have as a service provider? So I don't want to deliver massive IOPS in my service to any workload that my consumers want to run, but how much is that going to cost me? Remember, I said every architectural choice a service provider makes changes the bottom line cost of the service. So if I go high-end storage, large-scale storage, millions of IOPS, that's great, but my VM now, it's not $10 anymore, now it's $150 to provide that level of storage. And it's spread out across tenant because you actually have to make a capital expenditure to buy this massive amount of storage. So really, how do I build this storage environment out, handle any workload, the most demanding workloads, but how do I do it with cheaper commodity storage options? And that was one of the things that drove us in 2012. That's why we have things like storage spaces. Right? How many people have used storage spaces or have heard of it? Yeah. So how do we take JBOD disk and make it highly reliable, and also all the while by delivering demanding storage IOPS to a VM? Okay. So flexible storage options. You want to build a service that not only hosts virtual machines, but has the capability of being able to host just application workloads, because virtual machines is interesting, but you want to be able to host applications as well on this storage platform in a very performant manner. Now, our storage objectives is, one, to maximize the cost per terabyte, maximize the IOPS, all while leveraging commodity components. So when we look at this shared multi-tenant service, we think about how much does it cost to run the service? And that directly relates to storage. So what can we do in storage to make it cheaper? So if you look at this storage architecture, this is the storage architecture that, our North Star storage architecture for a shared multi-tenant IaaS service that you're using between the Hyper-V compute nodes. You have high, low latency connections with SMB Direct. SMB Direct runs over 10 gig Ethernet, uses RDMA cards in the environment. So this is all over-the-wire JBOD storage. Then you have the compute nodes, and now you're able to do tiering. Now, why is tiering important in a shared multi-tenant service? Some workloads require demanding gold-level storage, and that may be on SSDs. Other can be on cheap disks. So when you build out this service, this is what you want to allow your tenants to be able to select. If you need high IOPS, low latency, select Service X. Service X costs a certain amount of money that a user is willing to pay for a demanding service SLA. So you want to be able to tier. So it's important that you're able to tier storage out. This directly goes related into running your storage service as a part of your shared IaaS environment. And at the base, the bottom of the stack, not very complex storage, just JBOD storage. Running with storage spaces, being able to do dedupe of open virtual machine files, storage tiering, thin provisioning, adding all those SAN-like capabilities into a very cost-effective storage platform. So we talked about tiering and why tiering was important. It allows you to put characteristics of different storage types together and deliver that as a service. So think of your catalog now. You're a user and you're consuming a service. What are you going to run? I need a SQL Server instance. What type of storage? High IOPS, low IOPS, and they have associated costs associated with that. And that can either be on SSDs or on spinning media. And now that we have this storage environment, it's not just enough to have the storage environment, have all these different features. You need to be able to manage this at scale now. You're managing a storage service, not a server, a storage service that's delivering in-storage services to your tenant. So standard space management, the ability to scale it up, the ability to tier it, control it from, understand the capacity that you're using, the ability to extend the capacity out as well is important. And you do that by having standard APIs. If you look at the storage industry today has a lot of different players, right? There's a lot of different APIs to use. There's no unifying, overarching API that you can use to manage storage. So we wanted to have a single API that you can use to automate storage. Why is it important to automate storage in your service? Everything in your service has to be automatable. The network devices in the data center, the storage devices in the data center, including the hosts. So when you're provisioning a service, you need to be able to do this all from a single API, from an automation API that allows you to configure from compute, storage, and networking. So we added in a SIM API. And this allows you to configure storage spaces. It allows you to configure SANs as well, whether it be iSCSI or Fibre Channel. So you as a service provider can decide which storage platform you want to use, and you can have it automated for a single API, whether it be JBOD storage, whether it be iSCSI or Fibre Channel. All right, this talks through some of the scale-out server options with Virtual Machine Manager managing and tiering the storage out as for a service. Putting a face on file server storage, making it highly reliable, and adding additional disks to be able to deliver high IOPS in the environment. And we talked about classification. Why is classification so important? This allows you as a service provider to class tiers of storage. You can decide who gets gold, silver, or bronze storage, and that has an associated fabric tag associated with it, whether it be SSDs, spinning media, iSCSI, or fiber channel. Allows you to be very rich in classifying the storage, which in turn allows you to be very rich in actually billing out services as well to your tenants. Gold, silver, scaling it out, changing the configuration, whether it be a LUN associated with fiber channel or iSCSI. Okay. Networking. Networking gets a lot of press today, right? How many have heard the term software-defined networking? Right. Why is software-defined networking so important? You build out this service, and you think the thing that is going to cause you the least problems is going to be IP addressing and network devices. The thing that causes you the most problems is IP addressing and network problems, right? You talk about isolation, right? You try to isolate via the network. You try to provide security via the network. And then VM mobility is directly impacted by your network layout and the complexity you have in your network. So what were some of the network challenges that service providers face? Making this promise of network virtualization, moving VMs around any place in your environment, not worrying about the IP namespace, ultimate VM mobility, bring your own IP addressing. I love these different monikers that the cloud has, right? BYOI, bring your own IP, bring your own device, you bring everything, bring your own service, right? How do you make that real? So in 2012, we had the concept of network virtualization, but it took dependency on hardware-level gateways. So how do we make that promise real, right? And that was something real that Philip will talk about later as he tried to actually implement network virtualization, right? The other thing is site-to-site VPNs. Everybody's a tenant. So you as a service provider can say, sure, you can connect your enterprise with my service. And here's a site-to-site VPN. We have site-to-site VPN capability. Again, the great worst day is all of your tenants want to do this. Do you offer this service? Yes, we're willing to pay for it. Great. Because it wasn't a multi-tenant service, you had to deploy a site-to-site VPN gateway for every single one of your customers. Well, it sounds good in the beginning because they're going to pay, but when you have 2,000 site-to-site VPN servers that you have to manage, it makes the complexity of your environment scale out tremendously, which means the operating cost of your environment is high, and you have to have more people in the environment. Okay? So let's talk about what do we do. In 2012, we added the concept of network virtualization. So we talked about the Coke and Pepsi network, right? Coke, Pepsi, red, green, protecting against the different virtual machines running into different networks from communicating with each other, right? You did that via VLANs. Now this is policy-based. In the network's intelligent. You can have different IP just namespaces. As long as they're protected within a network, they never collude on the wire. But when you wanted to actually connect these via site-to-site VPNs, every one of these networks had to be connected with a separate gateway. You had to spun this out. You had 1,000 customers, you had to have 1,000 different gateways. Right? So one is unmanageable. You get back into, you move the VLAN problem from VLANs to now gateways. And if you ask the service provider would they rather manage 1,000 gateways or 1,000 VLANs, the VLAN problem doesn't seem too bad anymore. Right? So what do we do in R2? In R2, we added a software-based gateway that is truly multi-tenant aware, which means you can have multiple tenants using the gateway without you having to deploy additional gateways per tenant in the environment. It would allocate a pipe to specific tenants. And we also added the capability for you to be able to cluster it. It's not good enough if you've had one gateway. You're running a service. That goes down, then everybody loses site-to-site VPN capability. It's not good. So now you can actually cluster these software-based gateways. So one goes down in an active fashion. One goes down, you still have protection, still providing resources, site-to-site VPN resources to your tenants. Okay? We added BGP for dynamic routes. So now being able to take the concept of network virtualization and have dynamic routing in the environment as well. So to offer you true flexibility of being able to not manage routing tables and VLANs. Now a multi-tenant aware NAT. So if users were using NAT devices, you deploy one NAT gateway for all of your tenants. And multi-tenant VPN if you had customers that were using VPN or they were VPN into your resources as well. So you don't have to deploy 1,000 VPN servers in your environment per tenant. Okay, with that said, I talked through a lot of different areas. I wanted you to really get a sense that there's this North Star around the shared multi-tenant environment, and all these features, everything that I talked about, everything in R2 is specifically about making your service more highly available, cheaper, and giving you flexible options and being able to run in the network, storage, and management layer as well. Philip, I'll turn it over to you.
Thanks, Alan. Okay, so Alan's spoken a lot about concept. He's spoken about a lot of the investments that Microsoft made in 2000, and some of the stuff they've invested in 2012 R2. So let's talk about what's key to me as a service provider. And people get really shocked when I kind of talk about what's important to me. Well, I only care about two things. One, reducing my cost to serve, getting my cost to deliver my services down. Then, delivering functionality and capability that actually meets my users' needs. Ultimately, we have customers who buy from us. If we don't deliver services that meet their needs, they don't buy. We don't make any money. And that is the thing I care about, making money. We are a business. We are in the business of making money and providing IT services, which is the most unique thing about being a service provider. We are producing IT systems that ultimately are there to drive our business and make money. IT for us is our business. So let's kind of talk about what's important to us as NTTX. We are a service provider. And we have a number of pillars that we kind of build all our services around. We build next-generation services. Yes? So we build services around public cloud, true multi-tenant services, where our customers come to us and take multi-tenant working services, Exchange, Link, SharePoint, VDI, virtual servers. These aren't empty VMs. These are working services. Right? We're also doing a lot of stuff around hybrid cloud, external storage, backup, DR. So we can take all our customers from the smallest small to medium enterprises right the way through to the larger organizations and provide a gamut of services that meet their needs. But the key thing is we're delivering all of that on one platform. And I'll talk about that platform in a while, but that's the really key thing. We don't run multiple platforms, we're running a platform to deliver the service. But what's really key about our customer base? Well, they demand more. They demand more than they used to with their on-prem environments. They demand high availability. They don't just demand high availability, they demand continuous availability. And they demand geolocation agnostic access. Something I talk about a lot is the Facebook effect. People assume Facebook works globally. Yes. People expect our services to work globally, irrespective of location, irrespective of internet connection. And that's an enormous challenge when we're building services. So let's go and talk about some of the engineering goals that we went and looked at. So NTTX has been in the service provider market for a long time. And in fact, ever since NT4, in fact, when we first started doing this. And when we looked at Server 2012 and that came into the market, we looked at our engineering goals and we looked at what we could try and deliver on this cycle. We said, okay, we want to achieve a number of things. We want 100% virtualization. Every single service that we deliver runs out of VMs. There's nothing running on hardware at all. We want 100% automation. We don't want any engineers ever touching our servers and using UIs. We want everything driven through automation. And we want to do this in a way that delivers diverse workloads. So we can have things like Exchange, SharePoint, Link, VDI, SQL, all running concurrently. Because the interesting thing about service provider is that I don't know next month whether I'm going to have a whole bunch of users who want to do Link, or a whole bunch of people who want virtual servers, or suddenly I want a whole bunch of VDI sessions. I can't pre-predict. So I need a unified platform that can support those diverse workloads as we go through. It's an enormously important consideration. And then I've got to be able to do this in a way that drives true HA. And I've got to do this as an end-to-end platform solution. So we've looked at all those high-end deliverables, but then I kind of go, hold on. In my previous slide, I talked about cost reduction. So how can I drive costs down? Well, I can do that in a number of ways. We said, okay, let's get rid of the proprietary hardware vendors. Let's use industry-standard hardware, and let's cut out those middleware vendors. All those people who like charging us, 10,000, 20,000, 30,000 for a widget. Who pays their backup via the 10,000 for a widget that backs up Exchange? Know those stories? Yeah, we want to get rid of that. And the other key thing is that I don't want to drop £1 million or $1 million within the US into hardware provision at the front end. What I want to do is I want to buy my hardware in line with my customers as they come on stream. Now that's really important to me. But I've got to be able to do it in a way that is streamlined, automated, and can be easily done. And that's a really, really, really key set of deliverables. So we looked at 2012, and we thought, okay, is 2012 the platform to go and deliver this? And it was. So let's talk about some of the technologies we used. So Alan has talked about this storage network compute architecture. It's a very important thing to consider. So let's talk about that. So at the bottom end of the storage layer, we use the technology which was introduced in Service 2012, storage spaces, which I know some of the people in this room are familiar with. And, So storage spaces was a very robust, very efficient storage layer. We then coupled that with a scale-out file server. That's Windows being a storage delivery platform. But the beauty about that platform is that I'm getting it in box, I'm getting it with Windows, and I'm getting this highly scalable, high-performance file server. Then we use this new networking layer, this SMB transport, shares. Whack shares. Sorry, / shares. As a way of being able to get hold of data, get hold of resources. No more iSCSI, no more fiber channel. Let's use a nice flexible fabric in the form of SMB. And at the top, we talk about this compute concept. So we're now using Hyper-V. We're using Hyper-V in clusters, and we are driving forward all our services. And in our data centers at the moment, we actually use multiple clusters. So we have one general purpose cluster, which kind of does things like DNS, Exchange, Link, SharePoint. And then we have other clusters which are kind of dedicated towards the VDI workloads. Both graphics accelerated and non-graphics accelerated. And the beauty is we can move our loads around these hypervisors very efficiently. So we have this very clear separation between storage, network, and compute. We can scale each of these independently, and we're building the entire platform on cheap industry-standard hardware. And here's the really key thing. We can swap hardware vendors because the workloads are in the software stack, which is a very important thing for us. So let's look at our architecture in more detail. So, currently in the UK, we run 2 data centers, which I wonderfully here called Data Center A and B. And, as touched on before, we have cheap JBODs, just a bunch of disks, connected through Windows servers, then connected through industry-standard switching. Right? I have a saying that I like cheap, nasty switches. I don't need high-end switches. I just need switches that run standard WireSpeed connections. Yes? I'm not doing anything on the switch. I'm not creating VLANs. Right? I'm not needing any management layer on the switch. As long as it runs WireSpeed, I'm happy. And then I'm using industry-standard commodity servers to go and build Hyper-V aware or Hyper-V clusters. Yes? And the really key thing is, as a service provider, what I do through Cycle is I'm buying the most cost-effective kit as I go through, literally month by month. And the beauty is that I can now mix and match the hardware through Cycle, so I don't have to go and buy 64 nodes of the same equipment on day one. It's much more efficient from a cash flow perspective. So let's really talk about some of these architecture choices in more details. So storage spaces, wonderful technology. Previous to 2012, we were using SANs, storage area networks. Now, SANs are good, as long as you like paying lots and lots and lots of money. There are other talks on the SAN, so I won't go through the SANs versus spaces conversation. But the key thing to understand is that for us, we could take very cheap, dumb, just a bunch of JBODs, and then we connected those to standard Windows file servers. And because I'm a service provider, I effectively get those Windows servers for free under my licensing agreements as a service provider under SPLA. And what that gave me was a number of things that I couldn't get at an efficient price point from the SAN vendors. Critically, continuous availability. That's not high availability, that's continuous availability. What I mean by that is that a nuclear bomb could drop on one of my file servers, metaphorically, and the Hyper-V layer above wouldn't even notice, would just carry on working. That's a really, really, really key point. Zero outage on data delivery. Huge, huge benefits. Right. And then the other key thing is that, well, because I'm using these very cheap disks, these cheap commodity JBODs, and I'm using these cheap commodity Windows servers, I can scale. I can scale in a linear manner. And that's really important for me because with my SAN vendors, they said, oh no, you want more nodes? Here, have another controller. That'll be $120,000, please, sir. With Windows, I buy another piece of hardware, $1,500, and I drop Windows onto it. So I can scale my load independently of my requirements. And that's really, really, really important. And I can do it efficiently, and I can do it cheaply. Yeah. That is so important for me as a service provider. So let's talk about the next key layer. So I've spoken about storage. So now let's talk about this networking layer. And the key thing here is that we let Windows do the work. Okay? Windows now has a wonderful networking experience, end-to-end stack. So there's multiple things in here. So the first thing we look at here is that we can use cheap Ethernet networking. As I discussed before, iSCSI's out the window, fiber channels out the window. We're now using simple, reliable, understood shares. Windows shares, SMB. And these are changes in SMB3. So why is that important? Well, the first thing we do is it means that we literally decouple our compute layer, our hypervisors, from our storage layer. No longer am I manually, physically connecting fiber channel. No longer am I allocating LUNs over to individual hypervisors. Yes? No more iSCSI targets. Right? When I bring hypervisors on stream, I'm just pointing them at whack shares. The same things we've been doing for years to open up file servers. Huge benefit. Right? So let's just think about it for a second. I'm now being able to scale independently my hypervisors without doing any fabric modification. That's a very big change. And then you factor in other things that we get for free. So we now gain SMB multi-channel, which was a wonderful technology which was introduced in 2012, where we're now being able to, without teaming, yes, literally plug multiple NICs into the back of our servers, and they will automatically use all of those NICs. Now, why is this important for us as a service provider? Well, again, one of the things I do is I buy hardware a lot, and I buy different hardware. You know, I buy servers that have got 2 physical NICs, 4 physical NICs, 8 physical NICs. The nice thing about SMB multi-channel is that I can just plug the physical NICs in to these nice generic switches that I have, and then know that the NICs will be used efficiently. Windows just does it. The SMB multi-channel stuff just does it. Right? Nothing to do. No VLANs. No LACP NIC configuration on my switches. Nothing. Nothing at all. And I've touched on it here, and the other 2 key things we gain, of course, is we gain teaming inside the operating system, and of course we gain quality of service. Now, the nice thing about all of that is that, well, I'm doing teaming quality of service inside the OS. Oh, Windows has PowerShell and automation. So the same automation layer that I'm using for the rest of my system, I'm now using to drive my networking config. No additional team to go and look after networking, no additional learning curve. I'm driving my automation, my management layer using exactly the same technology that I did inside of PowerShell. Huge benefit for us. So let's wake up. Good, thank you. Okay. So let's now talk about Hyper-V 3, or the Hyper-V which shipped inside Service 2012. So when I started talking, I talked in terms of having these large clusters that can run multiple workloads. Yes, that's really important to us because inside those workloads, we don't know whether we're talking about, 10,000 VDI boxes or sharing 200 SQL servers. The requirements are very, very, very different. And one of the most wonderful things about Hyper-V 3 is that we could actually build out large, sort of 48, 50, 60, well, up to 63 nodes in fact, but we'll call it officially 64 node clusters. Right? That's an enormous amount of compute that we can deliver. Right? And that's in the box of Windows. So we haven't suddenly spent a whole bunch of money on some third-party middleware vendor. We're taking that out of the box in Windows. Right? And I'm being able to also inter-cluster migrate the VMs. Right? So that if I've got capacity issues inside one cluster, I can move those VMs from one cluster to another with 0 downtime for my users. Hugely important because if we have downtime, my customers start asking me for money back. And you know what? I really don't like giving people money. I really don't like doing it. Right? So other key benefits that we gained with Hyper-V 3. We gained dynamic RAM, which was, I'm sure people are familiar with the Server 2008 R2 Service Pack 1 changes in RAM allocation inside of Hyper-V. Dynamic RAM has been wonderful because we can start doing things like, let VMs boot up with very, very, very small amounts of RAM, yes, but then give their maximum RAM to a level where they run efficiently. Hugely beneficial on RAM utilization on our hypervisors. We run our hypervisors at over 90% resource utilization. Yes. You couldn't do that before. You just couldn't do it under Server 2008. You can do it now because of dynamic RAM. Huge improvement. Because remember, server utilization is money to us. It's a really key thing. And then 2 other key things to look at. So we now have virtual GPU support, what used to be remote FX. So we're now being able to drive forward fantastic 3D accelerated experiences for our user base. One of the things I rather like doing is going into companies that have Macs and saying, right chaps, get rid of your expensive Macs, take a VDI box from us, a virtual desktop, and we'll run your 3D CAD/CAM applications. Really, really satisfying when we do that. Massive growth industry for us. And the last thing I'll touch on here is the CSV cache, which is a piece of technology inside the scale-out file server. But the nice thing here is that it dramatically reduces the workload that we're driving across the network because we're caching regularly consumed parts of the file. Very useful for things like caching of the Windows partition and things like that. Very, very, very cool technology. So that was a whistle-stop tour of 2012. So let's look at where we got to in 2012, or where we're going to in 2012 R2. So when I started talking, I spoke about this driving down cost and making services that work. So I look at R2 and I say, okay, so I'm going to gain three things. I'm going to gain performance and scale over where I was in 2012. I'm going to gain cost reduction, and I'm also going to gain service improvements, extra stuff I can sell. And I like selling stuff. It makes me money. So let's look at some of the changes. Alan touched on this stuff. So storage, the R2 release of Spaces. So we're gaining the tiering, which Alan's already touched on, and we're gaining deduplication. Now, why is that important? We are projecting an 80% disk reduction with deduplication and tiered storage with Spaces. That's 80% reduction. Yes. I'm looking at some of our cost to serve for delivery of a VDI workstation. Yes. And that's going to take $4 off of my operational cost a month alone. Yes. Just with that one change. Right? And that one change is in box. I didn't pay some middleware vendor. Yes. You know, today we're running approximately a quarter of a petabyte of data. You know, I'm actually expecting our total utilization to drop considerably with deduplication and with tiered storage. Enormous cost benefits, and I'm still driving the same level of service, if not better, to my customer base. So let's talk about networking now. So the networking team has done a wonderful job, or more importantly, the scale-out file server team has done a wonderful job with this release. So if people are familiar with the CSV network concept direction, that kind of meant you had to run a separate cluster shared volume network, and that had cost and load. Well, because of the changes they've made to redirectional connections, that's all now been mitigated. So I'm going, that's good. I'm now being able to free up the investment I already had on switching and on network ports in the back of my scale-out file servers, and put that back into the pot of main compute. So I'm freeing up existing investments I had and actually making better utilization. Again, I'm getting it for free in the box, which is huge. The other key thing on the cluster layer is that we've now got the intelligent majority management. Now, this is really important because as a service provider, we regularly increase and decrease the cluster size, the number of nodes in our clusters. Now the cluster automatically deals with this stuff for us, right? So it's one less thing for us to manage, And it's also worth noting, again, under 2012, we were driving everything with PowerShell as the management layer. With 2012 R2, it's a very simple evolution of that existing management set. It's an extra property here, it's a small configuration change there. It's a very easy migration from the investment we made in 2012 into 2012 R2. Much nicer than what used to happen when we went from, say, Server 2000 to Server 2003 and everything changed. Those really were the bad old days. So now let's look at where we've got to in compute, or Hyper-V. So Generation 2 VMs. These are wonderful Generation 2 VMs because we finally get a grown-up VM architecture. We finally get rid of the BIOS, the virtual BIOS, it finally goes. For us, there's a number of benefits. It means that we finally get rid of the legacy NIC support, which means that our VM NICs get much faster, much more higher performance. I can get considerably improved throughput of my VMs. It means that when I'm starting to run very large VMs, large SQL VMs, large link VMs, I can get considerably improved performance. And then Alan touched on this, shared VHDX, one of my favorite subjects. So under 2012, when we had to do guest clusters for our clients, and we had a lot of them, we had to keep iSCSI. I had to keep an iSCSI infrastructure just to allow software iSCSI into the VMs to do the shared storage. So finally, we have shared VHDX. It's the same VHDX you have for the rest of your hypervisors. Yes? But now we're being able to place it down and then share it between two VMs. Huge benefit, especially for customers who've got line of business applications. Yes? So people come to us now and they've got some weird and wonderful line of business app, I don't know, something from an accountancy firm. And they're saying, I want to make this highly available. We can now do it using the shared VHDX solution, and they can gain guest-level clustering. Yes? And we can charge for this service. Alan was talking about this driving up the cost of the VM from $10 up to $150. It's these kind of services where you can really drive the value very efficiently, very cheaply. And then the last wonderful one is live migration between 2012 and 2012 R2. So I'm really glad Microsoft did this, actually. So we now have a situation where we've upgraded some of our hypervisors to 2012 R2, and I can in-place migrate my VM without taking my user base offline. Otherwise, I'd had to take services offline and charge people. That would have been a very, very difficult situation to deal with. So that jump forward alone makes a much simpler migration and means that I can keep earning money off my customer base as I go through it. So let's talk about some of the other key benefits. So I've spoken about storage, networking, compute. So let's talk about the stuff that I think makes me money, the service component, the extra thing we can talk. So remote app, I'm sure people are familiar with remote app in here. Remote app is a very popular experience. The user's taking an app as a virtual delivery onto various devices and experiences. The remote app team have done some wonderful work with this because they've added background transparency so that now the app feels much more like a local application. Really important for user adoption, you know. And they've also made a much better disconnection experience. I'm sure you're familiar with the terminal services client, that ugly box, and it all goes wrong and looks very unpleasant. So they've made some wonderful changes so that you get a much more graceful experience now. Looks a bit more like an app kind of freezing and recovering. Much nicer experience. And the other thing they've really done is they've jumped forward the virtual GPU performance and these shared scale enhancements. So that's really good because today I'm doing these great vGPU services, but it's kind of costing me a lot of money in terms of hardware. I'm not getting fantastic scale. So some of the scale improvements there are allowing us to take the existing investment we have in hardware and drive a higher user density. You know, there was a saying back when Server 2003 launched, which was do more with less. Right? And that really is how I feel a lot of 2012 R2 is. Doing more, in my case, doing more with the same investment in hardware. And that's a really, really, really important area. And then let's finally talk about hybrid cloud. So hybrid cloud's a very big thing at the moment. And it's also a really important thing to try and get the larger enterprises into the cloud space because they'll have IT managers who won't inherently move. They don't want to lose their jobs, basically. So one of the things I'm really excited about is that I can drop a whole bunch of new services which come out of R2, and I can drop them onto our existing portfolio and drive benefit to our customer base and acquire new customer base. So let's talk about some of those. So, you know, Alan's spoken about this, the RAS gateway, the multi-tenant gateway. So that allows us to now get rid of hardware or virtual firewalls. You know, today when we're trying to do multi-tenant with network virtualization, we've either got to drop in dedicated hardware firewalls for each tenant inside our data center, not a good idea, or run multiple virtualized gateways, right? Well, unfortunately, that means using VMware, which is not a good story today. And we end up running lots and lots and lots of them. You know, Alan touched on this comment about what happens when you suddenly get 1,000 customers all wanting to do that at once. It doesn't scale very well. So we're now getting a wonderful RAS gateway, and I spend a lot of time with the team talking about this, because I can now, inside of a VM, so again, I'm still maintaining 100% virtualization. Inside of a VM, I can create a highly available multi-tenant gateway, which means that each of my tenants can connect into my network through a secure site-to-site VPN or over direct access, and then be correctly natted into their own networks. So the Pepsi and the Coke analogy. Right. Huge, huge benefit. Remember, it's inbox. And then storage as a service. So we have the ability now to just very, very, very easily go into existing companies, and they're saying, oh, my server's a bit low on storage. What can you do for me? And now very easily we can go in there and actually give them a service that allows them to effectively make their distance bigger. Yeah. And it'll move data and it'll drop it off to the cloud very efficiently, very easily. It's a nice low-level service. It's a service you can go in easily with customers and say, take that. You know, they'll take some services from you, and then they'll go up the value chain over time. And in fact, I'll take this stuff out of order, but DR as a service is another great example of that, because you can go into the customer and say, that's fine, we'll give you off-site DR. You know, and we won't just give you one site off-site DR, we can give you two site off-site DR. So we can go secondary and tertiary DR because of the changes the Hyper-V replica team have made. You know, those services are very low impact for an existing infrastructure. You can put them in, you can charge for them, they work. Wonderful service to drive in. And then, one of the biggest topics at the moment, BYOD, bring your own device. The enterprise space is having an enormous challenge with managing devices. And one of the things I'm really excited about with R2 is actually for us being able to drive forward device management, application installation, encryption, remote wipe, all of those services, but being able to drive them as a commodity service and drive them into the existing customer base and into the enterprise sector as a service. It's a very compelling area at the moment because a lot of enterprises and all the mid-market companies right now are really struggling with how to deal with their own BYOD scenarios. And we can go in there and now drop a service. And we'll be able to take that on 2012 R2 natively out of the box. Huge benefit. And then the last one, which Alan also touched on, is the VM usage billing. So many years ago, we built an entire billing platform to go and do resource allocation and utilization billing. Well, I'm really glad that under R2 we can finally ditch all of that and actually take the stuff that they're shipping in box. Yes, which means that I can actually let Microsoft go and do that grunt work for me. And I can go and drive further value into the stack. Because we're now taking that stuff out of the box, which is a huge benefit. And actually, all of these hybrid IT services were things that I was either dabbling in before or wasn't driving that much profit and value. Or I was spending a huge amount of time engineering and solving the problems ourselves to build a proprietary platform. Now I'm being able to take this stuff in box, which means I can build the next generation of services. If you remember my opening slide, I spoke about producing future generation and advanced generation managed services. Well, this is the beauty of it. I can take this stuff in box, it works, it delivers to the customer, and then I can move forward and then drive the platform forward. And that's an considerable benefit. So, I think that's me done. So I think we've got about 5 or 6 minutes. So, any questions?
Yep.
You offer a service for patching guest VMs with security patching.
Yeah, okay, so the guest VM patching problem.
Repeat the question.
Yeah, so, so the question was, do we offer a service of patching guest VMs? So there are 2 parts to that question. For where we're doing true multi-tenant, so delivery as a service, yes, because we are looking after the VMs ourselves, right? And we have control of the underlying OS, right? When we are doing empty VM hosting, and the customer is actually extending their network, then we don't, because obviously the customer doesn't want to go directly inside the VM. Yeah, so that's your question. Anyone, go for it. So backup as a service, right. We do have a backup as a service offering today. And again, I haven't spoken about it today, but we consider it to be one of the entry-level experiences. Yes, and it happens, we actually drive that with DPM today. Yes, but you have to write some wrappers around DPM to actually make that work effectively. But it's quite interesting because there are a number of changes inside of R2 and some of the other services. That there are sessions on it this week, I think, actually. Yes, so there are some great options around backups as a service, especially for service providers.
Yeah, I think you want to, in Philip's case, you want to look at his services as 2 different types of services. If you're offering managed Exchange and Link and SharePoint, he's controlling the entire experience, the operating system, the application. He's providing backup of data for the application. If it's just an empty VM, then that's a service that he could provide, or he's hands off in the management of it, right? So either or. Service providers generally, everything for them is a service. So there's management as a service, they call it. So we'll patch it, update it, protect the operating system for you on your behalf for a fee, or we could just be outside of the process, allow you to provision an empty VM and go from there.
Yep. Yes. The true hybrid IT scenario.
Yeah.
Anything else?
Any more questions?
Go for it.
Yeah.
Actually,
Sorry, forgive me, I didn't see. Sorry, go for it.
we've been able to get any kind of server provision to be able to provide the updates for those clients, like 1,000 VMs, so that you're not having to do all those downloads from Microsoft.
So let me try and repeat that question. So let me try and paraphrase it. So I believe the question is, do we have a way of simplifying the update and patching process for unmanaged VMs where effectively we're providing empty VMs?
Or even providing the sort of WSUS type.
Okay, yes, okay, so the question is, how do we do our patch management? So in fact, we do use Windows Server Update Services, WSUS, and we have an internal infrastructure. And the nice thing about Windows Server Update Services is you can build that infrastructure to scale relatively well. Yes, and we drive PowerShell to create the automation. Yeah. So you can configure it that way. We only have a few customers that do it that way, actually, because it depends because remember, some of the customers have their own infrastructure anyway for doing it. Because if they're doing true hybrid cloud, they're just extending their network anyway. Sorry, forgive me, gentlemen.
What does your operations footprint look like with this fully automated infrastructure?
Forgive me, quantify operations.
Operational staff.
Okay, so the question was, what does our operational staff footprint look like? I love it when this question comes up. So we have 0 ops staff. I'm not joking, we have 0 ops staff. The reason we have 0 ops staff is because we drive everything from automation and from our management platform. We never physically touch our servers, ever. And the reason we never physically touch servers is because humans make mistakes. Even with runbooks, humans make mistakes. So everything we do, we actually drive from our management platform and drive for automation. That's one of the real powers of one of the real wins that we gained with PowerShell in Service 2012. Yeah. And it's how, Alan touched on this, automation is absolutely the key thing. Anyone else?
Yeah, they've built a very rich management layer, and you find this in different service providers.
Well,
You know,
I'm actually with the service provider. I work for USA.net.
yeah,
So,
yeah. Different service providers, take different approaches. Some of them actually build out very rich middleware and tooling, very complex middleware and tooling, CMDBs, the ability to manage multiple hypervisors in their environment, and this is stuff they've generally built out. Like one area that they built, like billing. There is no really consumable billing platform, right? They've got a lot of expertise in billing systems, right? You probably have a custom billing system in your environment because there was nothing to purchase out on the market that met a service provider's requirement around billing. So they have various levels of stuff they've integrated and engineered in that are very specific to the service provider space. That's one of the reasons why, moving forward, we want to focus on service provider requirements. If we take those requirements around billing and integrate it into the platform, that's just stuff that you can just use and consume, that you don't have to go on and out and build.
And I think there's another real value add here, because people often talk to me and say, well, hold on, if Microsoft's about to create something you've already built, doesn't that upset you? And I go, no, actually, it's fine, because then I don't have to keep maintaining it. Yeah? And that's something I quite like where Microsoft's going now, because as we go through the cycles, they're gradually chopping off the stuff I have to build in a bespoke way. And in fact, I commented on this earlier. And I think
so you can spend all your time just building services instead of building guts and infrastructure and tooling.
Indeed. Yeah. Gentleman in the mic, sorry.
You mentioned that you had no SANs in your infrastructure. So does that mean that every single VM and every single host is running on 73.0?
Sorry, so let me try and repeat the question. So I think your question was, I stated that there's no SANs in our environment, therefore everything's running over SMB3. Yes, correct. That is correct, yes. So we have no SANs at all. And in fact, even the stuff we're doing over iSCSI today, we actually do off the software iSCSI target. But that stuff will be discontinued with R2 because of shared VHDX. Yes. So, I'm a massive exponent of spaces. I was also hugely critical of it in the early cycle. But storage spaces has been a huge win for us, and Hyper-V over SMB has just completely revolutionized the way we build data centers. Huge. In fact, there are some case studies and white papers on the subject. And in fact, on Thursday, I'm doing a session around architecting. So, if you want to talk more about that, there's a Birds of a Feather, Thursday morning, if you want to come join them. Anything else?
Any more questions? No? Excellent. So we'll hang around for a little bit longer. If you have any more questions, come up, talk to us. And this is going to be a series, right? We only touched on 3 areas. We just touched on a little bit of compute, networking, and storage, but we didn't touch on identity and the identity problem in hybrid environments, right? Which I'm sure Philip has a lot of experience talking about, using Active Directory.
Space.
Right.
Yep.
Right. So we won't start that conversation. If you want to have a quick conversation about it, come up, talk to us. We're going to be continuing this series of talks around the cloud service provider architecture, and then drilling into various areas. What are we doing in Windows Server, and then how service providers are actually using it to deliver services. All right. So thanks for your time. Appreciate it.
Thank you.